Alright, so let's look at the second question. So this is the bandpass filter. Okay, something like that. Just a bandpass filter. Okay, and giving you a lot of information which we don't really need because the template has already been selected for you. So again, the first step is already been done, so we don't need to care too much about it. Alright, so the key steps here is again still the demonolize step. So we need to use this template and replace this S with is a band pass filter. So we always giving a low pass to band pass. You have this one. So we're gonna choose this one. Okay, this one have a S square on top and omega 0 square over a WS. And then what is omega 0 is this one, so it's related to pass frequency number 2 and number 1. And okay, W is omega pass number 1, 2 and number 1 as well. So this 2 frequency here, okay, is actually talking about here. That is the omega P1 and that is omega P2, okay, or F1 or F2. So it's 250 and 350. That's the passing band. Okay, so we're gonna start the step pre-wrap. Okay, so we're gonna have this omega P1 hat, which gonna equals to tangent. Okay, that's the equation, tangent 2 pi 250 hertz divided by 2 multiplied with sampling frequency 1000. That's for the first one. Okay, if you do the math, that equal to 1, and P2 hat is tangent 2 pi 350 over 2 multiplied 1000. This one is 1.962. Okay, and then we need to calculate this omega 0 square is the multiplication of these two frequency. Okay, is 1 multiplied 1.62 is 1.962. Okay, and this W S, or this W, this one equals to the first one, the second one minus the first one. Okay, so 1.9, the minus that is 0.962. Okay, okay, so this is actually not a subscript. This is S. Okay, multiply with S as a S. Okay, so next let's apply this step since we already got everything, and let's do this. So the third step, the normalize. So HAS hat gonna equals to HAS, and you replace that S with that number. Okay, S square plus omega naught square. Let's write this in a better way. Okay, divided by W multiplied with S. Okay, so this one equals to, our template is really simple, so 1 over S square plus omega naught square over ws plus 1. Okay, then if we clear the term, we have this SW over S squared plus SW plus omega naught 0 squared. Okay, after we got this, we can do the last step. So apply BZT. Okay, so H template, analog template hat, we're gonna replace that S with Z minus 1 over Z plus 1. Okay, so we got W multiplied with Z minus 1, Z plus 1. That's on the top. On the bottom, we have Z minus 1, Z plus 1 squared plus another W. Replace this one and plus a omega naught 0 squared. Okay. Then you can clear the term, make it in a better form, so and plug in all the numbers so we know all the W and omega naught 0 square. Okay, if you plug everything, then you should have a clear term, something like this. Okay, 1 minus that to the order of -2. So we want to have this 0 to a negative order because that's time delay, right? So 0.4904 Z to the order of -1 plus 0.5290 Z to the order of -2. Okay, that will be the final solution of this question. Alright, so again, first, based on all this, you should be able to find the order, and you can look up a table to find the analog template for low pass filter. Okay, for this question 1 and question 2, this analog template has been given to you, which simplify your work. After you get this template, you replace S with certain term based on which filter you're gonna have. Okay, and then you calculate this pre-wrapped frequency using this equation here. Okay, then you can replace this HAS and you plug it into it. Okay, then you have this HAS hat. The final step is replace S with Z minus 1 over Z plus 1 to bring it to Z domain. Okay, so you can find the coefficient to implement it in the digital circuit. All right, so that's the whole process.